Hello friends, in this video I'd like to solve the following problem from the Balkan Mathematical Olympiad 1987, problem number 1. Let a be a real number and let f be a function such that f of 0 is 1/2 and f of x plus y equals f of x, f of a minus y plus f of y, f of a minus x for all real numbers x and y. We wish to prove that our function is constant. So it's a fairly nice problem, I'd say. So here are my hints. First, set x and y to be 0 to find f of a. Then set just y to be 0. And finally, set y to be a minus x. So give this problem a try and I will see you in just a minute. Okay, so as I suggested, let's start with setting x and y to be 0. So set x and y to be 0 in our condition asterisk. Then we have the following: f of 0 equals, here we have f of 0, f of a, f of 0, f of a. So it's 2 times f of 0 times f of a. But what is f of 0? Well, it's not 0, that's all that matters. In particular, f of a must be 1/2 after dividing by 2. Let's remember that. Now, let's set something else. Now let's set just y to be 0. Set y to be 0 in our condition, which I mark asterisk. Then we have the following: f of x equals f of x times f of a plus f of 0 times f of a minus x. Very well, and now f of x is f of x. F of a is 1/2, as we know. F of 0 is also 1/2. So we have 1/2 f of x plus 1/2 f of a minus x. And after subtracting 1/2 f of x and multiplying by 2, we have the following: f of x, maybe let's write it in a different color, f of x is the same as f of a minus x. Okay, nice. And now, what can we do? Now I will set something else. Or maybe, let's also notice, maybe before I set something else, I will plug in our very first initial condition, instead of f of a minus y, we can put f of y, and instead of f of a minus x, we can put f of x. So maybe let's write that our condition asterisk becomes the following: f of x plus y equals f of x, f of y plus f of y, f of x. So 2 times f of x, f of y. And in particular, if I set x to be equal y, then we have the following: f of 2 times x equals 2 times f of x squared. And in particular, this is greater than or equal 0. So f of x is definitely greater than or equal 0 for every x. Let's remember that. And finally, let's set y to be a minus x in our very first, in our condition asterisk. Then we have the following: on the left hand side, we have f of x plus a minus x, so it's f of a equals, and on the right hand side, we have f of x, f of y, maybe let's f of x, f of y, maybe let's put it here. 2 times f of x, f of a minus x. Yes? But now, here we have 1/2 equals 2 times f of x. And what is f of a minus x? Well, f of a minus x, as we know, is f of x. So 1/4 equals f of x squared. And now we will use the fact that our function is non-negative. We can safely take square root on both sides, and we get that f of x actually equals 1/2 for every real number x, which means that indeed f is constant, which closes our proof because it's exactly what we wanted. So thank you very much for watching. I will see you next time. Goodbye.